शिक्षण प्रसारक मंडळs Kumarswami College Ausa. I heartily welcome all the respected dignitaries and participants here on the virtual dais for the national webinar. This national webinar is the part of a mega series of national and international webinars which was started on the occasion of the Golden Jubilee year of the institution. The theme of the webinar series is Women Empowerment, Women Dignity and Environmental Conservation. The objectives behind the webinar series are to exchange knowledge, to enrich knowledge, and through the discussions, question answer sessions after the keynote speech, all of us should try to find out answers to questions and solutions to problems so that these can be useful, fruitful and helpful for the individuals, the society and the nation. The webinar series is going on very successfully without any interruption, and the reason behind it is the strong academic leadership of the chief organizer and chairperson of this webinar series and moral support of the institution. In the beginning of this webinar, I welcome him as the chairperson of this webinar. Today I am very happy to inform you all that we have the keynote speaker, Honorable Dr. Nisha Varghese ma'am, who is an assistant professor at Krupanidhi Group of Institutions, Bangalore. She is going to deliver keynote speech on the topic Transition from Industry 4.0 to 5.0. On behalf of the organizing committee of webinar series, I welcome you ma'am as an invited speaker for this national webinar.
Thank you so much, sir.
Welcome. I have to welcome all honorable organizing committee members, Vice Principal Dr. S.D. Misal sir, Junior College Supervisor Ravindra Karanje sir, MCVC Supervisor Praveen Udge sir, IQAC Coordinator Dr. Sanjay Kale sir, Dr. Anita Dhole ma'am, Dr. Sudhir Garad sir, Dr. Patwari sir, Ambadas Khillari sir, and Dr. Wadkar sir. We all are here to listen the keynote speech by the speaker, but prior to it, I would like to request Dr. Anita Dhole ma'am for the introduction of today's chief guest resource person. Please ma'am, welcome.
Thank you, sir. Good evening, everyone. You are welcome to this grand national and international webinar series. On occasion of Golden Jubilee year of the college, Shri Kumarswami Mahavidyalaya Ausa has organized a wonderful grand knowledge sharing webinar series with the aim of women empowerment and women dignity. So, I am very thankful to respected Principal Dr. Bedkar MM for giving me this opportunity to introduce a resource person on this virtual platform. Many special thanks goes to all the respected organizing committee members and big thanks to all the respected participants. So I am here to introduce today's keynote speaker, Honorable Dr. Nisha Varghese ma'am from Krupanidhi Group of Institutions, Bangalore. Title of speech is Transition from Industry 4.0 to 5.0. Dr. Nisha ma'am has completed BSc in Mathematics, MSc in Computer Science, MPhil and PhD in Computer Science from Bhartiyar University. She worked as assistant professor on contract at University of Calicut as a guest lecturer at Calicut University. She has 8 years of teaching experience. She published a number of research papers on national and international levels. She got many certifications of different courses. She has coordinated many events like international seminar on research in computers, why, what and how, industry. Also coordinated 20 days webinar on cyber security. She has supervised various projects for MCA and MSc Computer Science, cyber security and data analytics students. Her interested areas are data analytics, text mining, natural language processing, machine learning, etc. So with this introduction, I would like to request today's keynote speaker, Honorable Dr. Nisha ma'am. Please start your presentation. Thank you. Welcome ma'am.
Thank you ma'am. Thank you Anita Dolly ma'am for your nice presentation, introduction about me. Good evening all. First of all, I would like to thank to all the organizers of the 1000 Days of National and International Level Webinar Series by Shri Kumarswami Mahavidyalaya Ausa. And my sincere thanks to the chairperson and principal Dr. M.M. Becker sir for giving me the chance, the opportunity to present again. And thank you Anita Dolly ma'am, Prakash sir and all other organizers and members that who are working behind these webinars, because we all are regularly attending participants. We know how the effort of they are taking every day, short time they are starting. So I welcome all the regular and active participants. We are daily meeting at this time. So today, this evening, I would invite you all to my topic as transition from Industry 4.0 to 5.0. Before getting into that, I just shall I present my PPT. I hope it's audible, it's visible for all.
Yes, madam.
Thank you so much. So when we are considering with the industry is a part of every economy and it plays the vital role in the economic development of every country, of all countries. Whatever it is, agriculture, mining, transportation, or restaurant chain, tourism, whatever it is, it plays a vital role in the development of the country, in the economic development of the country. With the proper and efficient functioning of these industries can deliver good quality products and services with the less amount. So today we are going to discuss about how the technology can improve or the technology can accelerate these kinds of industries. Before going to that, we are just going into the history of industrialization. And in 1780s, it started the industry 1.0. At that time, only machineries are used. In 19th century, industry 2.0 started. So at that time, electricity invented. And then after that, the development of computers, industry 4.0 started. And with the advent of internet only in 2000, it has started the fourth phase, industry 4.0. And now we are living in the industry 5.0. So today we are going to discuss about how we can transfer or how we can transform from industry 4.0 to 5.0. So first level is the mechanization is coming, industry 5.0. So at that time the revolution is happened with the help of steam engines and water like that. Industry in 18th century, industry 1.0. When we coming to the industry 2.0, electricity developed and combustion engines are used for industries and getting improved the industry as compared with the industry 1.0. When we move on to the industry 3.0 in its 1970s, so with the development of computer and information technology, the basic levels of industrial robots are developed. These kinds of basic level robots, it advanced the automation in the development of production or manufacturing like that. And this period is known as the information age. And next one is the industry 4.0. It is the period between 2000 to 2020, industry 4.0. So at that time, so many Internet of Things, IoT devices, which means whatever the devices we are using, if it is connected with Internet, we can say that Internet of Things. More than 50 billions of devices are connected by 2020. So how all these devices are collaboratively working, that we are going to discuss today. So it is an advanced computer system and industrial robots are developed at that time. And by this way, the production and industries are developed in a fantastic way. So what are the pillars of industry 4.0? We know we all are regularly attending participants of this webinar series. And in this industry 4.0, there are 9 pillars we can see here. Augmented reality, system integration, cloud computing, big data, IoT, 3D printing, cyber security, autonomous robots, and simulation. Some of the technologies we already discussed in the previous webinar series also. So some of the techniques we know already. But we are just basically, everything we are just discussing today. The first one is augmented reality. In the previous session also we covered the augmented reality. How it is working. Augmented reality is working with the help of any mobile or tablet or iPad. It is providing a mixed combination of the system or of the real world and with the device. We can see here 2 components are here, sodium and chloride. And he is stirring that two elements of chemistry, and after stirring it is getting sodium chloride as a salt crystal. And similar way, the augmented reality augmented reality is working. With the help of these devices, it is facing to a globe, and after that we can experience a real world. And together with that only, the augmented reality, virtual reality is coming. We can experience a virtual world. It is totally a fabricated world is coming in virtual reality. The second pillar is coming as system integration. System integration is coming with the engineering and information technology. It's an integrated system. How we can fetch the existing system with additional facilities. When we compare with the engineering and information technology, how we can add more settings to that. How we can add more systems or more facilities or software packages to the existing system. That is known as the system integration. In every area we can attach additional features or additional devices, equipments for proper synchronization. After with proper synchronization we can execute. So system integration is the fetching or synchronizing any kind of software or hardware, or depending on the domain we can attach that kinds of things. And next one is coming as the cloud computing. In our day-to-day life, we all are using these kinds of cloud computing and our technology. For example, we are using the email and we have all Gmail IDs are there. For a Gmail ID, 15 GB of data is provided. We can store our information in the Google Drive. We can share the information like that. And here, these are the various kinds of tools our third-party supports we can purchase by the amount, or some of the free services are there. We can store the data even the image or even a video or whatever it is we can store, even if it is database, server or whatever it is. So this is the cloud computing. It's delivery of different kinds of services through the internet. We can use varieties of applications are there in between these cloud computing. For entertainment also, on-demand video, music, database, email, communication, data analysis, whatever it is, we can use with the help of cloud computing. And these are the some kinds of services are there providing by the cloud computing. Three services basically are there: software as service, platform as service, infrastructure as service. So using that services, some kinds of applications we can use, some kinds of application we can build or develop, and after that these developed things we can migrate, which means we can deploy. Okay, and likewise we can utilize this cloud computing, and we may all are familiar with these kinds of digilockers. Sorry, so digilockers we are using in our mobile is providing 1 GB of data to store our documents. By the similar way, our Indian government is providing one facility as Meghraj Cloud. We can open this by using the cloud.gov.in is by Indian government, and we can log in and we will get our own dashboard. What are the services that are providing? We can utilize that. And next pillar is coming as the big data. Big data, which means our data, the usage of data is, this is some of the statistics, or usage of our day-to-day activities or sharing or disseminating the contents in a is growing in a very multiple ways. It's growing. For example, here we can see that it's a growth of the 15 years of graph is here. Now it is in 175 zettabyte, which will come in 2025. Now we are in 2022. So 1 zettabyte which is equal to 10 raised to 21 bytes. So how much we are using the data? We are transferring the data. So when we are discussing about the big data we can classify into 3 types. Basically, so many types of data are there, but basically we can divide it into 3 types: structured, semi-structured and unstructured data. Structured data, which means it's purely organized, properly organized data is known as the structured data. With the help of some softwares like SQL, Oracle, like that softwares we can use, like databases we can use to store the data. And semi-structured data, which means it is not fully structured, it is not completely unstructured. It's a half of the way. In the computer terminologies, we can say that email is an example of semi-structured data. Some kinds of markup languages, XML, HTML like markup languages. And for example, some kinds of books, if our newspapers or exam sheets, that and all the example for unstructured data, because there is no proper organization or it is not organized in a proper way. But some kinds of books like, for example, some holy books like the Bible and the Quran and all. The Bible and Quran, it is divided the book into named chapters. In that named chapters in Bible, it is named ordering, it is arranged. After that, chapter-wise ordering is coming, and each sentences are also numbered. When we consider Quran also, it is 114 chapters or 30 juz as it is divided, and each surah or each juz has an ayat that also numbered. So if you want to find the 19th chapter or Maryam chapter, verse number 50 or ayat 50, if you are considering that, that is unique. That kind of data we can also say that semi-structured data. Unstructured, which means, for example, newspapers like that, there is no proper order, or some kinds of reports, there is no proper order. coming into the picture. Why? Because the usage of data is growing exponentially. And not only that, the type of the data is also very important. For example, Beckers needs to collect the feedback of our webinar series. He's asking to give as a report or something like that. What are the ways are there? We can give the voice messages to him. These are the suggestions, or these are the things in the webinar series, and we can send the report as text, and we can send the videos also, and we have certificates also as image, and YouTube links are there. So these are the different types of data: text data, image data, video data, and audio data. These are the various kinds of data. So if you want to extract the exact feedback of the webinar, we want to analyze all these type of data. So data isn't heterogeneous. All data is heterogeneous. To merge all these data, after integration of these data, wants to extract what is the feedback of this one, or what are the suggestions related to the webinar series. So that kind of purpose, we can catch the big data and its framework. Why? Because it's a huge volume of data is there, and data is in different types also. Then we need to analyze from the data to get the specific insight from that. That is known as the big data. For that, there are so many technologies inside the big data to extract, to analyze these kinds of data. Big data framework is there. These are some of the companies that exploiting the potential of the big data. So many companies are here. Everyone is utilizing the potential of the big data and its framework support. Like Facebook, we are using, Amazon is there, Stack Overflow, eBay is there, IBM, Intel, LinkedIn, Twitter, Spotify. So many companies are in our day-to-day life we are watching. How they are extracting the feedback of persons, how they are improving day by day by the suggestions. Or if they are giving the suggestions or feedback, how they are improving the product quality. And these kinds of things, it will help, these big data can help. The next one is we are going to the Internet of Things. We already discussed that. What are all the devices that we are using in our day-to-day life is connected all these devices together with the help of Internet. And 15 more billions devices are connected through the Internet by 2020. So how the Internet or IoT are executing and IoT working? In previous sessions, some other resource persons already discussed how IoT is working. The same way only. There are some kinds of sensors are there. Sensors are the small devices to collect the data. And after collecting the data, it can connect through any kind of the networking facilities. That may be Wi-Fi or any kind of networking or internet or that kinds of wide area network or LAN facility. Like that we can use to transfer the data. And after that the data will be stored and it will be processed, and finally we will get the result. So here the technology using sensors are for the data collection, so devices for IoT, and networking is using here to store the data. To storing data we can use the cloud facility. We already discussed the cloud. Here we can, in cloud we can store the data. Otherwise any kind of databases we can use to store the data. And after that, with the help of these kinds of big data or any kind of machine learning and deep learning we can use, and after that we can retrieve the result as a user interface. In our day-to-day life, we all are wearing these kinds of digital devices like smartwatches. How they are counting the vibration or number of steps we walked. by the vibration sensor. By the vibration sensor, and after that we are getting that today it's 10,000 steps we walk. Like that it is displayed. So these are all the processes are happening inside it. Whatever the devices, even if it is mobile or gadgets, electronic gadgets. And these are some kinds of sensors that we are using. So here air sensor, infrared sensors are there, water overflow sensors are there, rain sensor, soil moisturing, heartbeat sensor, alcohol sensor, gas sensor, detecting the leak of gas, and smoke sensors, color sensor, humidity sensor, so many sensors are there. So at the time now we are watching, at that time we may think, what is the use of, we are discussing about these sensors. But in our day-to-day life, we are using, knowingly or unknowingly, we are using so many kinds of sensors. Even if we all are using our mobile phones daily, how many sensors are there inside it? See here. For day-to-day life, we are using our vehicles. So inside a car, there are more than 50 sensors are there to detecting, to collecting various kinds of data. And in our mobile phones, based on mobile phones, 12 to 15 sensors are there to collect the data. To find the GPS, to find the accelerometer, humidity, to if the temperature is increasing, we will get notification in our mobile. And for vibration, we all are using touch sensors, touch, fingerprinting. That all are the various kinds of sensors. So even if we are not bothering about these kinds of things, also in our day-to-day life, we all are using. And how the IoT is connecting, using any kind of networking we can use, or we are using headsets, we are using wireless headsets. How it is connecting with our mobile phones? With the Bluetooth only. And some devices we can connect with the Wi-Fi. And some devices we can use WAN, for example, Ethernet we can use. Low-powered WAN, cellular, satellites. For long connectivity we can use satellites. So any of these connection mechanism or networking mechanism we can use to connect these devices together. And when we think about the point of view of industry, more than IoT, more than normal IoT, IIoT plays a vital role. Industrial Internet of Things. What is happening there? One example I can tell you. And we discussed in the previous sessions also some kinds of dustbin by the movement it detecting. Here also for the waste management, how collaborative way these techniques are working. This is one of the efficient waste management system. Here we can see here garbage cans are here, and with the sensors, if the garbage cans filled with the waste, it can already put message to the cloud system. This is the cloud using, cloud computing. From this cloud, they can inform whatever the authorities or concerned person like city council, recycling plant, manufacturing plant, and health and safety authorities, or whatever the concerned persons or organizations we need to inform. From this cloud, it is informing them. So here place the IoT devices are connecting, and cloud is also. This is one of the example of collaborative working of these methodologies. So this is one of the example for industrial IoT, how it is working. And not only this one, if more than 50 billions of machines are connected together, then what will be the output of that? Everything we can execute with the help of the strongly connected things. Because everything are connected, we can inform real-time data. And the next one is one of the example of how a smart world can develop with the help of this industrial IoT. Not only IoT, the data, big data, the analysis, cloud computing, and everything. What are all the pillars inside the Industry 4.0? How it is collaboratively working? How we can develop a smart world? Now we are thinking, is these things are possible? Like that we will think. But it's happening. Why? Because in 20 years back, we never expect these kinds of smartphone we are using. The entire world is in our hand. It will come like that. We never think that kinds of things. So in the smart world, you can see some kinds of labels here. For air pollution, we can detect with the quality of air and the amount of carbon dioxide and other kind of gases, toxic gases inside it. And fire forest detection, like some kinds of radiation levels from the factories, and traffic congestion, smart roads we can, how the waste management going, how the water quality, is it good water or not, the quality of shipment. If some types of goods some kinds of food and beverages if we are sending, what is the temperature of that? Is it still in cold or not? That kinds of, or the structure of the bridge is right. Is there any vibrations are happening there? Like that, all kind of techniques, or for detecting these kinds of small things, we can easily detect with the help of this technology. So before making any problem only, these small types of variations in the results of, even if it is gas, even in the vibration or whatever it is, it can fix as possible early. So in like that way, we can create a smart world. And next technology is the 3D printing. 3D printing is also known as the additive manufacturing. Additive manufacturing, which means that we can develop any kind of three-dimensional object with the help of these technologies. We can just go through one video. I hope this is visible.
Yes, madam, yes.
These kinds of robots can help the humans in a collaborative way with the humans. They can create. What is the advantage of that? As better than human working, it can make all these things in a fast and efficient way. So humans and robots are working in a collaborative way. So this is known as additive manufacturing. Any kind of objects we can create, or these kinds of three-dimensional boards we already seen, boards we can create, or even homes also we can prepare. Within a minimum time we can create the homes also with the help of the huge robotic support. Next, one of the important component inside this 4.0 is cyber security. We all are living in the world of digital world we are living. We are all are using electronic devices, gadgets and all. So we have to be aware of how we can protect our devices, how we can protect our computer and other networking system and our data. Data is one of the most important assets nowadays. So we are thinking we all are free from these kinds of attacks. Never it will happen like that. We are thinking, but actually, what is happening? These are some kinds of attacks, malicious attacks are there. You can check one of the live statistics, how in a day-to-day life, how it is going. This is one of the real-time map. Okay, cyber threat real-time map is this one. So this is the globally now, it's a real-time map of globally affecting various kinds of attacks. So it's United Kingdom. It is the 18th most attacked country. We can just rotate the globe and we can check the countries. What is the statistics of that? Belgium, 49th. Germany, the third most. Likewise, which country we want, like that we can rotate the globe and we can check country. Or India is the 11th most attacked country. So these are some of the statistics that are largely happening these kinds of attacks. And here if you are going to this map, you will get the statistics and where they collected all these data and real time how they are projecting all these things are. We can go and check. And so cyber security is very important. Why? Because we all are not, nothing is hidden in this world. Everything is open. So we have to aware about these kinds of security rules, principles and some cyber laws also. So these are some of the malicious attacks I listed. Some of them are affected to some kinds of files or data. Some of them are maybe affected with the databases and some related to the operating system, some related to the networking, related that various kinds of attacks are there. Some kinds of ransomwares. They will take the control over the system or control over the data. And later if we are ready to provide the ransom also, we are ready to provide the amount only they will retrieve the data back. So some of the preventive measures are, we should be aware of these kinds of things. We should regularly change the passwords or strong passwords they have to be used. And some preventive mechanisms like always go with the secure site or use the antivirus in our systems and good firewalls we can use and download good quality software from the trusted site only. We have to download all these kinds of things. And always back up our data. If the data loss or system is also lost, then only if we are backing up the data or we are storing, these kinds of cloud computing services are very good and they are achieving the higher security. So we can store the data in that level also. And secure, don't ever go with the free Wi-Fi and all. Secure Wi-Fi always use. That kinds of some principles and some basic tips are there to avoid these kinds of cyber attacks. Next one is the autonomous systems. Autonomous systems simply we can say that's a human superpowers. Human superpowers, which means it's collectively we can say that maybe you may heard about autonomous car like Tesla, autonomous robots, autonomous drones, helicopters. Autonomous helicopters are developed by Stanford University. So how these systems are working and how these systems can help the industry to develop in an accelerated way, how it can collaboratively work. We can go a small video. Of KUKA company from Germany. This is one of the video of KUKA, the company from Germany. They are developing so many manufacturing robots. They are manufacturing robots, various kinds of manufacturing robots they are developing in their human.
Forward thinking, safety, sustainability, global.
Value chain, smart factory, operation technology, processes. Robotics, robotics, robotics. I am upstate. All by robotics, industrial.
Okay, this is one of the example of a Kuka company from Germany. All over in India also they have some branches, and they are manufacturing various kinds of robots. Actually, it is not robots. They are in their advertisement also. Just I've seen in there they are telling it's cobots. Cobots, which means collaborative robots. It's collaboratively working with the human for an efficient, because if we are humans and working for a specific thing, it is if we are creating 10 identical things also, the 10 we cannot say it should be identical. But if it is designing in a computer and these kinds of robots are doing these kinds of things, the 10 or 100 should be identical without any change. In this same company we have seen some cars are there. So in this company, they are developing 828 vehicle bodies. So which means every 77 seconds, they are creating one vehicle body. So the advantage is when compared with the human, better and faster and more reliability it can provide. And more intelligently it can work than the humans. Why? Because nowadays it is not robots, it's cobots. The difference between that, cobots are following some kinds of quality standards like ISO. That guidelines they are following, and they are autonomous also. Some thinking powers are there, some decision making powers are there with the help of the big data or machine learning and with the help of deep learning also. And when we will see if these kinds of robots are playing the role of human, what we will do? We will be jobless. That kinds of thinking also will come. But not all works cannot do by the humans, because we all are humans. We have limitations are there. Some kinds of problems it is not possible to manage by the human being. Like the complicated thing like a bomb diffusing. Or some persons, they are trapped in earthquake, that kinds of places. Or someone trapped inside the mines. Human cannot go inside that. So robot can get into that. It can check with the help of the sensors, heartbeat sensors, or temperature sensors. Like that, it can check inside that. It can identify the presence of humans inside that. They can frequently send the photos and videos of what is happening inside to the outside world. So varieties of uncountable applications are there with the help of these kinds of robots. And the final pillar of the Industry 4.0 is the simulation. Simulation is similar to the 3D printing like that. But 3D printing is the real object. But simulation is a model we are developing with the help of a computer and its softwares. So we can, before creating the original product, we can fetch or we can find out the possibilities, or if it is working like that, we can analyze and check, and later we can fix it, or later we can produce the real object. How the simulation is help at the time of industry, or how it can reduce the cost at the time of industry. If you are making a product, if it is useless, there is no other way.
Simulation 3D modeling is a procedure whereby a process or system is imitated using computer models representing the key or process in question. The model represents the system itself. The simulation represents the operation of the system over time. The cost of introducing a new product to the market can be immense.
We can develop with the help of any kind of softwares these kinds of objects, or some kinds of tools and machines like that. First we can design and we can fetch or synchronize these kinds of objects to the existing system, and we can check that is it
Prototype phase is
working.
among the most expensive. Prototypes must be designed, tested, modified, and tested again. These tests often expose flaws in the design that require moving several steps back in the process and starting over, hence the expression, back to the drawing board. Thorough testing is vital. If the more thoroughly a product is tested, the slower and more expensive the production process becomes. Physical prototypes are a drag on the budget and project timetable because they must be manufactured. It is necessary to use expensive physical models for all phases of the testing process. The foremost advantage of simulation 3D modeling is its ability to use computers to take over. Unlike physical prototypes, computers speed to market, production performance, and customer satisfaction. Because testing is computerized, simulation also reduces safety hazards and allows users to study.
So before developing the entire product, we can create the demo of the product or a tool or machine, whatever it is, and we can fetch the machine to the existing system. If all configurations are okay and it is working properly, then we can go for the production of this model. Okay. Otherwise, if we are roughly we are creating, if we are developing, that also will be increase the cost of industry. So by the way of simulation, we can reduce the cost also, the effort also. Now the next one is with the help of these simulation. Not only the simulations are coming here with the help of simulation. Here, this is one of the, you can see, this is one of the military persons. They are experiencing how if it is really happening, how the if war is come to reality or it's coming. At that time, how he wants to respond to that. Or here some astronauts, before they are going to the space or some other planets, they can experience the real world, what that will be in the space or some other planet. Same experience. These are the some of the rules for that, special rules for that developed by the NASA. So what are all the, these are the examples for simulation also. What are all the real thing we have to be experienced in the future? It will be trained before that also. So they will be adjusted with the environment and adjusted with all the systems and facilities. So it will be more helpful when they all these things become reality. Not only the simulation, with the help of the augmented reality and virtual reality, everything can be used in a collaborative way. This is one of the example of a pilot. He is training. Actually, this is a room space, but he is experiencing as he's doing his work. He's inside the real flight. He is like that an experience we will get, or even driving car also, or we are in the education purpose also. These kinds of simulation will help, like in medical field for some kinds of operations also. For medical students, they can study well. So So all these 9 pillars of Industry 4.0 can collaboratively work. That is one of the advantage. And here we can see that robotics is here. Here in one, robotics is here. And second one, cloud computing use. We can store the data. And big data we can use for analyzing. And wireless communication networks are here. An embedding system we can use. Smart storage systems. And logistics supply chain management. Everything we can work in under an umbrella, like in a collaborative way we can work. And when we moving to the so many advantages are the productivity, efficiency, flexibility, customer satisfaction. It can reduce the cost and improve the income, improve the revenue. So many advantages are there. So we already discussed about Industry 4.0. When the transitions to Industry 5.0, it is like a harmony of how humans and robots are working. Cognitive computing or cobots. So when we coming to this, some more advanced things are will come, like drones, automated drones, self-thinking power to deliver the product, exoskeleton, some additive technology we can wear, or if they are going for war, if they are getting into the mines, or if in the cold place, or the hot higher temperature, like that, exoskeletons they can use to survive. And some additive technology, we already seen the 3D printing, and more than that, we can use some kinds of technology to create. And now we are in the world of 5G. And if it is going to 6G and beyond, the faster communication is possible. And mixed reality, with the help of augmented reality and virtual reality, we can work for education, for entertainment, or for games, or whatever it is we can use. And industrial blockchain, one of the important things. We can do all the transactions and we can make our data in a secure way with the help of industrial blockchain. We can transfer with the help of cryptocurrencies like Ethereum, Bitcoin, like that we can use in blockchain. So this transition is happening, the robot to cobot. It's a collaborative way, how the systems or these kinds of robots are collaboratively working with the human. And who will bridge the gap between this Industry 4.0 to Industry 5.0? We all are the answers for that. All stream engineers, data analyst, data scientist, data engineer, mathematician, statistician, and who all are can contribute. We all can contribute. We have to be expertise. And one more thing is, we all are human. We have to consider the humanity. And in previous session, we discussed about one of the important thing of Google Duplex. The Google Duplex, they developed to improve or to accelerating the common people industry. They are not facilitating any kind of website support or any kind of internet support to improving or accelerating that kinds of small scale industry. They developed the Google Duplex like that. So we have to be focused the development of the low-level industries and the common people. The technology we have to be made for that. And here, Industry 4.0 is connecting people together, machines together, and data. So in a collaborative way, like a cobots, it's a collaboration, it's a harmony between the human and these kinds of technologies coming in Industry 4.0. And this is all from my side. Thank you. Thank you all.
Thank you, ma'am, for your very good speech on the topic Industry Transition 4.0 to 5.0. Now, after this keynote speech, I request participants, if you have any question or doubt, please ask.
questions?
Sir, we continue now.
The keynote speech was illustrative, elaborated very well, and so all of us have understood about it. So after this keynote speech, now I would like to request the chief organizer and chairperson of this webinar series, Honorable Principal Dr. M. Ambedkar sir, for his concluding words. Please sir, welcome.
Thank you, Professor Karad sir, all the organizing team committee members, including IQ Shikwad, Sanjay Kale sir, daily joining, Prashant Ugade sir, Dr. Jamuntrao Kadam sir, Utge sir.
Sir, we are not listening you.
Yes, thank you, Professor Karad sir. It's muted by me. And today's resource person, Dr. Nisha madam, all the organizing team committee members, including Dr. S.D. Misal sir, Dr. Sanjay Kale sir, Anita Dole madam, daily joining members, Ugade sir, Praveen Udge sir, Karanje sir, and all the participants and the resource person of our webinar series. Today's topic was the transaction from industry 4.0 to 5.0. Most of the commerce peoples, those who daily join here, they might be asked question about it, but they today as opposite our Badudi sir, all these things. But those who are from commerce side, they are I think well and good understood by this, because PPT was very so clear with audio, video and animations, and particular explanation is related to all the pictures. Right from the generation of the industry, she came up to the stimulation of the last part of that from it was the journey from robot to cobot. So we are from science side but not think so much about this, and you explained all these things, how, what about generation, what was the improved stage at that time, how it affect upon human resources, everything was so clear. And in future this will go in again ahead, because we need some products which within few months or within short time. At that time manual use of manual power is, I think it's unwanted one, because they will cannot complete the work within that particular period. So this type of cobot will do everything as per the demand of the industry. As you have said that they can build home also, they are supporting us in every daily useful things where the manpower is where we will use the most accurate work. So it was the new concept by you, by for us, and you have explained very nicely. I thankful to the Krupanidhi industry, your institution, because you 3-4 resource person have joined here because of your contribution. Our series come ahead in 4 to 5 webinars ahead. Thank you, madam. Very nice presentation.
Thank you so much, sir. Thank you all the organizers and participants. We are daily meeting all of you. And thank you, Becky sir, once again for giving this opportunity once again. Thank you so much. Thank you, Winston sir, Ravi Shankar sir, who introduced me to
Yes,
this platform.
I have forgotten his name. I have forgotten Ravi Shankar. He is a daily joining member. Sometimes he discussed before joining starting the webinar, and you also appeared here second time.
Winston sir also, he is a regular participant.
Regular participant.
Yes.
You also, I see daily to you for joining here. You are not away from a webinar series, and it will go up to 2nd July in the first part. In second part we will start again, and we will invite you again, madam. Thank you.
Thank you so much, sir. Thank you.
Thank you, Dr. Bedka MM. Thank you. You are doing a great job. Wonderful job, sir.
Thank you.
And thank you. Thank you, Nisha ma'am.
Thank you,
Thank
sir.
you. Thank you, everybody. Thank you. Good evening to all of you.
Good
Thank
evening,
you, sir.
Good evening, sir. You are daily joining, inspiring to all of us. You are senior most person of this webinar series. Thank you,
Yes,
sir.
sir. Yes, sir. Thank you. I'm a senior most but very young at heart, sir. Thank you.
Thank,
God bless all of you, sir.
thank you, sir.
May your webinar continue up to your what date you have made in mind.
Yes.
Congratulations, sir. You're doing a great job.
Thank you.
Thanks, sir. Good evening, sir. Bye, sir.
Now at the end, I am here for out of thanks. I would like to thank the honorable keynote speaker, Nisha ma'am, who has accepted the invitation of our college and spared her precious time to enlighten us on the topic. And the topic was very illustrative, and it was supported with the audios and videos, and so all of us have understood it very well. So on behalf of the organizing committee of the webinar series, the Kumarswami College Ausa, I sincerely thank you, ma'am.
Thank you so
I
much.
also thank chief organizer and chairperson of this webinar series, Honorable Principal Dr. M.M. Bedkar sir, who is a source of inspiration for all of us, and he is the power bank of the webinar series. And because of his continuous efforts and tenacity, the webinar series has become a reality. And so on behalf of the organizing committee of webinar series, I thank you, sir. I also thank all the participants who are joining from different parts of the country and also from abroad. They are very regular and punctual, and they are taking active part in the question answer session and listening the keynote speeches patiently and meticulously. And so the webinar series is becoming successful. Thank you, participants. I also thank Dr. Anita Dole ma'am for giving introduction of today's honorable keynote speaker. And now I request participants, please fill feedback link which has been posted in the chat box. We have your certificate. And at the end, with the permission of chief organizer, I announce here that today's webinar is over. Thanks to all. Thank you very much.
Thank you, madam. Thank you.
Thank you once again, sir. Shall I leave?
Yes, yes. Thank you.
Ma'am,
Thank you, sir.